everyone, this is Mrs. Padmashri from SNS College of Technology. Today, I am going to explain the concept of dropout in machine learning. This is the continuation of my previous lecture video, Dropout in Machine Learning. So, understanding the dropout concept based on regularization. So, already I had explained about what is dropout in my previous video. So, in this video, we are going to understand why we need to drop out and why we need to regularize the network. So, the meaning regularization, dropout regularization explains the concept of dropout during the training process in deep learning model, okay, which specially solves the problem of overfitting, which leads to high bias and low variance in the network, in the neural network. So, which in turn affects the performance of a model. Okay, so we need to regularize the output. So, for getting the better performance of the training model, we are going to focus on this dropout regularization. Okay, during this, I am going to explain a recap of my previous video. What is a dropout regularization? During any training process, the dropout randomly deactivates. So, the particular chosen neurons will be dropped out and the connections will be terminated within a layer, which means the neurons are dead. So, when we say the neurons are alive, it means the neurons can able to transfer the data from one layer to the another layer. If we say the neurons are dead, which means the neurons cannot transfer anything. So, that can be checked by using activation function. This I had already explained in my previous lecture videos like AN and artificial neural network videos. So, activation function properly checks the particular neurons or nodes in the network which is properly active or which is transmitting the information from one layer to the another layer, right. So, this is the basic concept. So, the deactivated neurons are chosen randomly for each training iteration. Randomness is very difficult. It's very crucial and it's for preventing your overfitting. So, these all already we had discussed priorly, right. So, directly we can go on to this particular diagram. What is this? Is a standard neural network. So, initially I showed you ANN, right. So, you will be having input layer, output layer. In between there will be some hidden layers. They say the nodes which is shaded as red in color, which means that the nodes are dropped out, which is not involved in transmitting the data. And see, it is deactivated. There is no connection between one node to the another node. There is no connection between one layer to the another layer. So, this is called a drop out. Sometimes you all can ask why we need to drop out the particular node. We can keep it as it is, right. Let it be present in the network only. So, no, because it affects the performance of the network. It will take more time. The processing time will be more. See, one data will be receiving the data, or it checks for activation function, processing the data, and then it transmits to the other node, right. So, in between, if there is another node is there, what happens, it simply transmit and this will not do anything and these nodes are dead and it will not transmit the data to the next layer, means it is just a waste of time, right. It makes the network more hectic and it is what to say, it affects the performance. That's why this concept is very important in machine learning. So, how will you implement this dropout in deep learning model? So, implementing this dropout in deep model, this procedure can be extensively enhancing the generalization of neural network. The dropout is typically implemented as a separate layer which is inserted after a fully connected layer in the deep neural network architecture. Okay. So, this dropout rate, which is the probability of dropping the neurons. Say, for example, the 50% of the neurons are dropped out. So, that is the probability out of 100 percentage, we are dropping the 50 percentage of the neuron. So this is the dropout rate is a hyperparameter that has to be tuned for optimal performance. We have the concept called hyperparameter tuning, right? The X, Y parameters are tuned to achieve the better performance. Tuning means that adjusting the values of, adjusting the parameter values. Okay, so the same concept is implemented here. Start with dropout charge of here 20% neurons are dropped out and adjusting upward 50% based totally at the model overall performance with 20% being a great baseline. Okay, so with this we can implement PyTorch model. Dropout is implemented through the use of the torch.nn model, neural network module. Okay, so you can use this links also in Keras. Utilize tf.keras.layers.dropout function to add dropout to your model. You can use these two things. And let me discuss about the advantages of dropout and also the disadvantages of dropout regularization. When advantages, it prevents the overfitting by randomly disabling the neuron, and the network cannot rely on the specific connections between them. And ensemble effect. Whenever I say ensembling is a grouping of the nodes or grouping of the data together. Okay, so ensemble effects, the dropout acts like training an ensemble of smaller neural network with varying structures during each iteration. So this effect improves the model's ability to generalize to unseen data. Okay, grouping of the different structures of the neural network. So enhancing, the third advantage, enhancing the data representation. Dropout method used to enhance the data representation by introducing noise, generating the additional training samples, and improving the effectiveness of the model during the training process. Some of the drawbacks of dropout regularization is there because we have many advantage like prevent overfitting, ensemble method, enhancing data are enhanced, but here we have some of the drawbacks and how to mitigate. Based on this benefits, dropout in deep learning is not without its drawback. You will be having the drawback. Some of the challenges we have to think over that. Longer training time, as I already said. So whenever we have the dropout nodes in the network, it takes more time, longer training time. Dropout increases training duration due to random dropouts of units in hidden layer. So here to address this problem, we need to parallelize training wherever is possible. Then optimization is complexity. Optimization will be very difficult. Understanding why dropout works is unclear, making the optimization challenging, and experiment with the dropout rates from smaller scale, and you need to fine tune your model performance. These are all the drawbacks. And also some of the points, like as I said, hyperparameter tuning. Dropout adds hyperparameter like dropout chance and learning rate requires a careful tuning, and use the techniques as grid search or random search to systematically find the optimal combination. We can use these grid search or random search for finding out the optimal combination. Then the another one is redundancy with batch normalization. It sometimes replaces the dropout effects, and we are going to evaluate the model performance either with or without the dropout by using the batch normalization. You all know that batch, instead of considering a small data, we are going to consider a batch of data sets. Okay, that is batch normalization. Then finally we have a model complexity. Dropout layers add a complexity to the network. So the model architecture, where possible, we can ensure the dropout layer is justified by performance again in validation. So these are some of the drawbacks that we have to overcome in dropout regularization methods. Thank you so much. Thank you for watching my video. Keep supporting my video. Thank you all.